to gray. And we can display this. So just to know that we're on the same footing, I'm going to run this. So Python contours.py. And we get a gray image over here. Now after this, I want to essentially grab the edges of the image using the Kenny edge detector. So I'm going to say Kenny is equal to cv.kenny. We're going to pass in the img and we're going to give it two threshold values. So 125 and 175. And we can display this image, calling this Kenny edges, pass in Kenny. Let's save that and run. Close it out. I didn't save that. Save that and run. And these are the edges that were there in the image. Now, the way we find the contours of this image is by using the find contours method. Now, this method basically returns two things: contours and hierarchies. And essentially, this is equal to cv.findContours. This takes in the edges, so Kenny, and it takes in a mode in which to find the contours. Now, this is either cv.reta_tree if you want all the hierarchical contours, or the reta external if you want only the external contours, or reta list if you want all the contours in the image. The next method we pass in is actually the contour approximation method. For now, we're going to set this to cv.chain_approx_none. So let's just have a top-down look at what this function does. So essentially, the cv.findContours method looks at the structuring element or the edges that were found in the image and returns two values. The contours, which is essentially a Python list of all the coordinates of the contours that were found in the image, and hierarchies, which is really out of the scope of this course, but essentially it refers to the hierarchical representation of contours. So for example, if you have a rectangle, and inside the rectangle if you have a square, and inside of that square you have a circle, so this hierarchies is essentially the representation that OpenCV uses to find these contours. This cv.reta_list essentially is a mode in which this find contours method returns and finds the contours. Reta_list essentially returns all the contours that finds in the image. We also have reta external that we discussed. Reta external retrieves only the external contours. So all the ones on the outside, it returns those. Reta_tree returns all the hierarchical contours. So all the contours that are in a hierarchical system, that is returned by reta_tree. For now, I'm just going to set this to a list to return all the contours in the image. The next one we have is the contour approximation method. This is basically how we want to approximate the contour. So chain_approx none does nothing. It just returns all of the contours. Some people prefer to use chain_approx simple, which essentially compresses all the contours that are returned into simple ones that make the most sense. So for example, if you have a line in an image, if you use chain_approx none, you are essentially going to get all the contours, all the coordinates of the points of that line. Chain_approx simple essentially takes all of those points of that line, compresses it into the two endpoints only. Because that makes the most sense. A line is defined by only two endpoints. We don't want all the points in between. That, in a nutshell, is what this entire function is doing. So since contours is a list, we can essentially find the number of contours that were found by finding the length of this list. So we can print the length of this list. And we can say, grab that there. And we can say, these many contours found. Okay, so let's save that and run. And we found 2,794 contours in the image. Now this is huge. This is a lot of contours that were found in the image. So let's do a couple of things. Let's try to change this chain approx symbol to chain approx none and see what that does. See how that affects our length. Now, there isn't any difference between those two because I'm guessing that there were no points to compress since there are a lot of edges and points in this image, so there wasn't a lot of compression. So let's change it back to simple. And actually what I want to do is I want to blur this image before I find the edges. So let's do a blur is equal to cv.gaussian blur. We can pass in the gray image and we can give it a kernel size of, let's do a lot of blur, so 5 by 5, and maybe we can give a border default of cv.border_default, and we can, if you want to, and we can display this image, call this blur, and pass in blur, and we can find the edges on this blurred image. So let's call this blur. And as you can see, the significant reduction in the number of contours that were found just by blurring the image. So it went all the way from 2,794 to 380. That's close to 7 times just by blurring the image with a kernel size of 5 by 5. Okay, now there is another way of finding the contours, is that instead of using this canny edge detector, we can use another function in OpenCV, and that is thresholding. So I'm just going to comment this out, and down here what I'm going to do is I'm going to say ret thresh is equal to cv.threshold. This will take in the gray image and will take in a threshold value of 125 and a maximum value of 255. Don't worry too much about thresholding for now. Just know that thresholding essentially looks at an image and tries to